Hello class, welcome to Algebra Concepts, Lesson 5-2, Day 3. Today we are talking about parallel and perpendicular lines. By the end of this lesson, you should be able to find the equation for parallel and perpendicular lines given an equation and a point. So let's first recap what parallel and perpendicular mean. So parallel lines are lines that do not intersect and have the same slope. So this picture is an example of parallel lines. If we're looking at equations, you'll notice that their slopes are the same. So right here and right here, both of them have slopes of 1/2. So since their slopes match, they are parallel. Then looking down at perpendicular lines are lines that intersect at a right angle, which means 90 degrees, and have opposite reciprocal slopes. Okay, so let's talk about what opposite reciprocal means. Opposite means if it was positive, now it's negative. Or if it was negative, now it's positive. Okay? So that means that when you're comparing two slopes, one's positive, one's negative. Reciprocal is where you flip a fraction. Okay? So if I have the slope 1/2, okay, so it's positive 1/2, my opposite reciprocal would be negative. And then instead of 1/2, now it's 2/1. Okay, so, and then this is a picture to help you see what perpendicular lines look like. So let's practice a little bit more with the parallel and perpendicular slopes. So if we're looking at the original slope being 7/8, our parallel slope would be the same. Our perpendicular slope would go from positive to a negative, and it would go from 7/8 to 8/7. Our original slope is -3, so our parallel slope is -3. That means our perpendicular slope would be positive. Instead of 3/1, it's 1/3. Okay, and then our next one, our original slope is -9/5. Our parallel slope is -9/5. And our perpendicular slope is going to be positive 5/9. And then our last one, original slope was 1/6, so our parallel slope is 1/6. Our perpendicular would go from positive to negative, and then it would go from 1/6 to 6/1, or just 6. Okay, so that's how you find your parallel and your perpendicular slopes. So if you have any questions with that, please ask for some help right now, because if you don't understand this slide, it's going to be really tough to move on and move forward, okay? So if you understand that, let's jump into example 2, parallel lines. So we want to write an equation of a line in slope-intercept form. So let's remember slope-intercept form is our y equals mx plus b. So we want to write an equation of the line in slope-intercept form that passes through the point 8, 9 and is parallel to the given line. So if we look, here's our given line, y equals 3/4 x minus 2. So we're going to pull this information right here, the point. So we have the point 8, 9, and then we have the slope 3/4. And since we're talking about parallel lines, we're going to keep that slope the same. We're not going to change it at all. Okay? Now, yesterday and the day before, we talked about point-slope form. So we have a point, we have a slope. We're going to use the point and the slope to write a new equation. And you might be saying, but Ms. Johnson, it's asking for slope-intercept form. And I'm going to say, well, good thing yesterday in the last video, we talked about how to go from point-slope to slope-intercept form. So let's jump right in. And let's remember our point-slope form is y minus y1 equals m times x minus x1. So I'm going to say y minus 9 equals my slope, which is 3/4 times x minus 8. Okay, so I've got it in point-slope form. Now my next step is going to be convert it to slope-intercept form. So I do that by distributing first. So 3/4 times x is just 3/4 x. 3/4 times 8, or times a -8, is -6. And then all I have to do to get it to slope-intercept form is I have to move the number that's with the y. So I have to add 9 to both sides. So I say y equals 3/4 x. -6 plus 9 is going to be +3. And that's my answer. Okay, so I took the point, I took my slope, I kept my slope the same because it's parallel. I plugged my point and my slope into point-slope form, and then I converted it to slope-intercept form. Okay, so those are the steps. Why don't you go ahead and try this one on your own? Good luck. Okay, hopefully you ended up with y equals 2x plus 11. So the way I got that was I kept my slope of 2. I used my point -3, 5, plugged that into point slope form. So I said y minus 5 equals 2, and then in parentheses, x minus a -3, which becomes x plus 3. Then I distributed my 2, so this became 2x plus 6. Then I added 5 to both sides, and that's how I got 2x plus 11. If you have any questions about that, please be sure to reach out for some help. I'm happy to help you. Let's move on to our next example. Okay, so we, in this example, are finding a missing value. So this is going to kind of tie into something we did back in chapter 4. So hopefully it won't seem too tough, but I also know that this is something that can be a little tricky. So make sure you take good notes on this example. So we have a line passes through the points A, 5, 6, and then B, 10, n, and is parallel to the given line. What is the value of n? So if we're talking about something that's parallel, right away, I know that my slope is going to equal -2/5 because that's my given slope. And now I want to figure out what value of n gives me this slope, okay? So what I'm going to do is I'm going to use my slope formula. So y2 minus y1 over x2 minus x1. I'm going to rewrite that because it was pretty bad. There you go. Equals your slope. So what I'm going to do is I'm going to start with my n as my y2. So I'm going to say n minus my other y, which is 6, over, and then since I started with n, I need to start with 10 minus 5 equals, and then I'm just going to put the negative with the 2, but you could put it with a 5 and you'll end up with the right answer as long as you don't totally get rid of the negative, and as long as you don't make both of the numbers negative, okay? So as long as this negative is just with the 2 or with the 5, you'll get the right answer. Okay, so now what I'm going to do is I'm going to cross multiply to get rid of the fractions. So I now have 5 times n minus 6 equals, and then I'm going to multiply these two things. But before I multiply these two things, I'm going to simplify this. What's 10 minus 5? That's just 5. So I have 5 times the -2 on this diagonal. So 5 times -2 is just -10. Then from there, I can distribute if I would like, and I can say 5n minus 30 equals -10. I can add 30 to both sides. So then I would have 5n equals 20. Divide both sides by 5, and I get n equals 4. I'm going to show you one slightly faster way. So starting at this step, if you wanted a slight shortcut, because I know sometimes you guys like shortcuts, you can do this instead. So instead of multiplying the 5 into the parentheses, you can actually divide both sides by the number that's outside of your parentheses. So in this case, that's a 5. So then I'm left with a -2 over here. And then you're just left with whatever was in the parentheses. And then you can add 6 to both sides. So you can see I ended up at the same answer. It's a little shorter, not much. So if you feel comfortable, if you feel more comfortable just sticking with the same thing every time, I recommend you do this method. If you're okay with sometimes having a slightly different way, you can do this shortcut. But that is up to you. All right. Now, I want you to do the same type of problem. This time, our variables in our x value. So that means the variable is going to be on the bottom of that fraction that you set up, okay? So we have a line passes through the points A, n comma 3, and B, -1 comma 7, and is parallel to the given line. What is the value of n? Good luck. All right, for this problem, hopefully you ended up with n equals -2. And the way I got that was I said 3 minus 7 over n minus a -1, so that became n plus 1, equals 4 over 1. So then I cross-multiplied. I said 4 times n plus 1 equals. Then I simplified this. I said 3 minus 7 is -4. Then I did -4 times 1 is -4. Then I distributed that 4, and I got 4n plus 4 equals -4. I subtracted 4. Careful, some of you like to make this a 0 instead, but -4 minus 4 is going to be a -8. And then -8 divided by 4 is -2. Okay, so if you have any questions about that problem or anything else, please be sure to reach out for some help. Let's move on to our next example. So now we're going to practice writing an equation of a line in slope-intercept form that passes through the point 4, 5 and is perpendicular to the given line. So I'm still going to use that point. So I have the point 4, 5. But now my slope was a positive 2 over 1. So now it's a -1 over 2 because we're talking perpendicular. But then your work is going to match the same process that we did earlier in the video, where we say y minus y equals our slope times x minus our x. And then we're just going to simplify. So we're going to say y minus 5 equals -1/2 x plus 2, because I distribute that -1/2. And then I just add 5 to both sides. And since the 5 doesn't have an x, it doesn't impact this -1/2 x. It only gets added to the 2. So 2 plus 5 gives me 7. So I am all done with that problem. So the only thing you need to remember with perpendicular is to change the slope. Okay, so why don't you go ahead and try this one on your own. Good luck. All right, for this problem, hopefully you ended up with y equals -4x plus 23. You hopefully pulled down the point 4, 7, and then you got the opposite reciprocal of this 1 over 4, made it a positive to a negative, so our perpendicular became a negative, and 1 over 4 became 4 over 1. And then you just plugged it into point slope formula. So you said y minus 7 equals my slope, which was -4, times x minus my x, which was 4. And then you distributed -4 times x, -4x. -4 times -4 is positive 16. Then you added 7 to both sides to get y equals -4x plus 23. Okay. If you have questions about that at all, please be sure to reach out for some help. I'm happy to help you. Let's move on to our last example for today. So now let's practice classifying lines. So if I give you two equations, I want you to be able to tell me, are these two lines parallel? Are they perpendicular? Or are they neither? Okay, so the best way to do this is, well, the only way to do this is to find the slope of each line. So this one right over here, that's easy because it's already in slope-intercept form. So I know my slope is -3 over 4. But over here, I don't exactly have my slope easily written. So what I can do is I can convert this. It's pretty close to being in slope-intercept form. The only thing stopping it is the fact that I have a 3 right here. So I'm just going to divide everything by 3. So my equation will become -4/3 x plus 2. Okay, so now it's in the same form, and I can see that my slope is -4/3. Okay, so now I have my two slopes, and I would want to see, are these two slopes the same? That would make them parallel. Negative 4 over 3 is not the same thing as 3 over 4. So I know it's not parallel. And then perpendicular means that I have two slopes that are opposite reciprocals of each other. So if I look, I have 4 over 3 and then 3 over 4. So they're reciprocals, but since they're both negative, that means they're not opposite. So they cannot be perpendicular, which means these two equations, these two lines, are neither. They're not parallel and they're not perpendicular. Okay? So then what I'm going to have you do is classify these two lines. Are they parallel, perpendicular, or neither? Good luck. All right, for this problem, hopefully you said the slope for y equals negative 5x. Your slope is negative 5. And then for 25x plus 5y equals 1, maybe you remember from yesterday, the way that you find slope from standard form is you do the opposite of a. So it was positive 25, now it's negative 25, divided by b, which was divided by 5. Negative 25 divided by 5 is negative 5. So my slopes are both negative 5, which means that these two lines are parallel because they are the same, or they have the same slope. Okay, so that's our last example for today. If you have questions about this problem or anything else in this video, please be sure to reach out for some help. I am happy to help you, and I hope you have a great day.